Something is happening right now across the Pacific that I have not seen discussed anywhere near enough. And when I put all the pieces together for this video, I have to say it stopped me cold because we are not talking about one earthquake. We are not talking about one region having a bad week. We are talking about the entire western arc of the Pacific Ring of Fire showing coordinated movement. Indonesia, New Zealand, Cascadia, all of them simultaneously right now. And the question that every seismologist quietly asks in moments like this, is this random or is the Pacific Plate doing something we need to take very seriously? Stay with me through this entire video because I am going to show you something that the headlines are not connecting. The individual events are being reported separately. A quake here, a tremor there, an alert somewhere else. But nobody is zooming out and showing you the full picture. I'm on the pulse for you, and this is what I found. So let's start with Indonesia, because that is where the most recent and most dramatic signal is coming from. In the past several weeks, the Maluku region of Indonesia has been struck by a series of significant earthquakes. We are talking about a magnitude 7.6 in Tonga, feeding stress eastward. We had the magnitude 7.8 event in the Maluku Sea. USGS revised figures placed it between 7.4 and 7.8 as data came in. And this happened in one of the most geologically chaotic zones on the entire planet. I want to explain why Indonesia is different, because when people think about earthquake zones, they think about one plate going under another. Clean, simple, predictable, right? Indonesia is not that. In the Maluku region specifically, you have something that scientists call double subduction. Double subduction. That means the small Maluku Sea Plate is being consumed from both sides simultaneously. The Pacific Plate pushing from one direction, the Australian Plate pushing from another. And this tiny plate caught in between is being crushed, being bent, being destroyed from two directions at the same time. So when stress finally releases there, it doesn't release cleanly along one fault. It releases chaotically across multiple fault systems at once. And the energy from that release doesn't stay local. It radiates outward through the crust, through the mantle, through the entire connected plate system. And that is exactly what appears to be happening right now. Further down in this video, I'm going to explain why Cascadia, sitting on the other side of the Pacific, is not immune to what happens in Indonesia. I'm going to show you what the data from New Zealand is telling us. And I'm going to explain why scientists who study stress transfer between fault systems are paying very close attention to the pattern we are currently seeing, because this is not quiet behavior. Right? So now let's talk about New Zealand, because this is the piece of the puzzle that most people are missing entirely. New Zealand sits on the Alpine Fault, one of the most dangerous and most studied strike-slip faults in the southern hemisphere. This fault runs almost the entire length of New Zealand's South Island. It is over 800 kilometers long. That is roughly 500 miles of accumulated tectonic stress. And here is the critical fact. The Alpine Fault ruptures in a major earthquake approximately every 250 to 300 years. The last major rupture was in 1717. That is over 300 years ago. The fault is overdue, significantly overdue, and scientists working on the Deep Fault Drilling Project, which has been drilling directly into the Alpine Fault Zone to study its behavior, have described the current state of the fault as late in its seismic cycle. Their words, not mine. Late in its seismic cycle. That means stress has been accumulating for 3 centuries. The fault is locked. It is loaded. And it is sitting in a region where the broader tectonic system around it is now being disturbed by a sequence of major earthquakes in the Pacific. GNS Science, that's New Zealand's Geological and Nuclear Sciences Institute, has documented increased seismicity across parts of the North Island in recent months as well. The Cascadia Subduction Zone, which runs along the east coast of New Zealand's North Island, has been showing slow slip events. These are episodes where the plates move against each other slowly and silently over weeks or months rather than in a sudden violent rupture. Slow slip events, guys, they matter enormously because what slow slip does is it transfers stress. It loads adjacent locked sections of the fault. It is essentially the tectonic system preparing itself, shifting weight, redistributing pressure. And when that transferred stress reaches a section of fault that is already critically loaded, that is when you get a major earthquake. The Hikurangi margin is capable of producing a magnitude 8 to 9 earthquake and associated tsunami that would hit New Zealand's east coast within minutes. Minutes, not hours. And GNS Science has publicly stated that a major Hikurangi subduction earthquake is one of New Zealand's most significant natural hazard risks. Right now, that system is showing slow slip activity, while the broader Pacific system around it is producing major earthquakes in rapid succession. Let that sink in. And I did some research on the historical record here because this pattern is not without precedent. And what I found was striking. In the lead up to the 2010 magnitude 8.8 Mal earthquake in Chile, the region had also been showing a period of increased slow slip and moderate seismicity. Scientists looking back at the data after that event noted that the fault had been communicating its state of stress through smaller events for years before the main rupture. The main shock didn't come from nowhere. The system had been talking. People just weren't listening loudly enough. I'm not saying New Zealand is about to have an 8.8. I cannot say that. Nobody can say that. What I am saying is that the signals coming out of New Zealand right now deserve far more attention than they are getting. And combined with what we are seeing in Indonesia and what I am about to tell you about Cascadia, the overall picture is one that should make every seismologist lean forward in their chair. So, Cascadia, this is the one that, if you live on the west coast of North America, you need to hear. The Cascadia Subduction Zone runs approximately 1,000 kilometers. That's over 600 miles. From Northern California all the way up through Oregon and Washington State and into British Columbia in Canada. It is a megathrust fault, the kind of fault that produces the largest earthquakes on Earth. And it has been locked. Building stress. For over 300 years since its last full rupture on January 26, 1700. The 1700 Cascadia earthquake is estimated to have been magnitude 9.0 or greater. It generated a trans-Pacific tsunami that struck Japan. Japanese historical records documented the wave arriving with no warning earthquake felt in Japan because the source was so far away, but the wave crossed the entire ocean, and since that rupture in 1700, the fault has been locked, accumulating strain at roughly 4 centimeters per year in the central and northern sections. That is over 12 meters of accumulated strain over 325 years, over 40 feet of stored elastic energy in the crust. Now, here is what makes the current moment different. The Pacific Northwest Seismic Network has been recording an unusual uptick in low-frequency earthquakes beneath the Cascadia Zone in recent months. Low-frequency earthquakes, guys, are different from regular earthquakes. They happen deeper in the transition zone where the locked fault gives way to the slowly creeping fault below. And they are often associated with episodic tremor and slip, another form of slow slip, another form of stress transfer. At the same time, GPS monitoring networks along the Pacific Northwest coastline have documented subtle but measurable changes in ground deformation patterns. The coast is being compressed, slowly, as the Juan de Fuca plate continues to drive eastward beneath North America. And the strain is not releasing in small earthquakes the way it does on more active fault systems. Cascadia is almost entirely silent seismically in its locked zone. That silence is not reassuring. That silence is what a fully locked megathrust fault looks like when it is storing energy. Oregon State University researchers have estimated that a full Cascadia rupture today would produce a magnitude 9.0 or greater earthquake, shaking that would last 4 to 6 minutes, not seconds. Minutes of continuous violent shaking across the entire Pacific Northwest. and a tsunami that would hit the coast of Oregon and Washington within 15 to 30 minutes, with wave heights potentially exceeding 30 meters in some locations. That's close to 100 feet. Seattle, Portland, Vancouver, all within the impact zone. And right now, as I am recording this, Indonesia is shaking. New Zealand's subduction zone is quietly slipping, and Cascadia continues its long, locked silence. So, the question that I know you are asking right now is the same question I asked when I started putting this video together. Are these events connected, right? Is what happens in Indonesia capable of influencing what happens in Cascadia? And here is the honest scientific answer. And I want to be accurate here. I want to be precise. Direct mechanical stress transfer over the distance between Indonesia and Cascadia, thousands of kilometers, is considered to be weak. The direct stress loading that one fault can impose on another drops off dramatically with distance. So, in that sense, an earthquake in Maluku does not directly push Cascadia closer to failure in the way that a nearby earthquake might. But there is a mechanism called dynamic triggering, and this is real. This is documented. USGS has confirmed that large earthquakes can dynamically trigger seismicity at great distances through the passage of seismic waves. The waves from a major earthquake travel through the entire planet. They pass through every fault system on Earth. And when those waves pass through a fault that is already critically stressed, already close to its failure threshold, they can provide the final nudge. It is not a clean domino effect. It is not Indonesia falls and therefore Cascadia falls. It is more like, imagine a table covered in mousetraps all loaded and set. You shake the table gently. Most of them don't go off, but the ones that were already teetering on the edge, the ones that were already at their threshold, those are the ones that snap. Cascadia has been at or near its threshold for decades in geological terms, and right now the table is being shaken repeatedly. In January 2025, we had the major activity in Tonga and Vanuatu, then the Maluku magnitude 7.8. We had the South Shetland Islands magnitude 7.0 near Antarctica. We are seeing distributed major seismic energy release across multiple sections of the Pacific system within a compressed time window. The Pacific plate is not quiet right now. It is not behaving the way it behaves during calm periods. The energy release pattern we are seeing is spatially distributed across the ring in a way that stands out. And I want to be very clear. I am not saying the big one is coming tomorrow. No scientist will tell you that, and anyone who does is lying to you. The honest answer is that earthquake prediction at the level of time and place does not exist yet. We cannot say when. We can only say that the conditions currently observable across the Pacific Ring of Fire represent an elevated state of activity that warrants serious attention. But here is the thing that really got me when I was researching this. I found something in the historical record that I think is deeply relevant. In the period between 2010 and 2012, the Pacific Ring of Fire experienced a remarkable cluster of major earthquakes. February 2010, the Chile magnitude 8.8. September 2010, the Christchurch, New Zealand, magnitude 7.1. March 2011, the Tohoku, Japan magnitude 9.0 and devastating tsunami. April 2012, two magnitude 8.6 and 8.2 earthquakes off the coast of Sumatra, Indonesia. Four major seismic events, four different regions of the Ring of Fire within roughly 2 years. After the Tohoku earthquake, researchers published studies examining whether the prior large earthquakes in Chile and New Zealand had contributed to the loading of the Japanese fault system. The conclusion was nuanced. Direct causation could not be proven, but dynamic triggering was considered plausible, and the remarkable coincidence of timing across different sections of the ring within such a compressed window was noted by multiple research teams. We are now seeing a similar pattern of distributed major energy release across the Pacific system. Indonesia is moving, New Zealand is showing stress signals, Cascadia is locked and overdue, and the broader Pacific plate is releasing energy at multiple boundaries simultaneously. This is not random bad luck. We cannot say that with confidence. This is what an active stressed tectonic system looks like when it begins a period of accelerated adjustment. Now, I want to talk about what this means practically. What should people do? What should authorities be watching? What are the next indicators that will tell us whether this pattern escalates or settles? For Indonesia, the key watch points right now are aftershock depth patterns. Are subsequent events getting shallower? Is the activity spreading laterally along the fault system? And of course, tsunami monitoring buoys across the region need to be fully operational. After recent events, DART buoy networks, those are the deep ocean assessment and reporting of tsunami systems, need to be verified as functional. After budget issues in some Pacific monitoring programs in recent years, there are legitimate concerns about gaps in coverage. For New Zealand, the focus should be on the Hikurangi slow slip event duration and extent. GNS Science publishes updates on slow slip events. If the current episode is larger than typical, if it extends further along the fault, that is a signal worth watching closely. And of course, the Alpine Fault remains the sleeping giant. Any unusual seismicity in the South Island should be taken seriously given the fault's overdue status. For Cascadia, the Pacific Northwest Seismic Network data, GPS ground deformation measurements, and critically, whether the current pattern of episodic tremor and slip changes character becomes more frequent, moves along the fault toward the locked zone. Those are the indicators that matter. And I have to say something about preparedness, because this is the part that actually has the power to change outcomes. The Cascadia region has a preparedness problem, a significant one. Studies by FEMA and Oregon's Office of Emergency Management have modeled a full Cascadia rupture scenario. The numbers are confronting. Potentially over 10,000 fatalities, hundreds of thousands of buildings damaged or destroyed, infrastructure across the Pacific Northwest compromised for months to years. The I-5 corridor, the main artery connecting California, Oregon, Washington, and British Columbia, crossing multiple bridges that are not designed for a magnitude 9.0. Many of those bridges would fail. The tsunami inundation zones along the Oregon and Washington coasts are home to communities that in some cases have fewer than 15 minutes to reach high ground after the shaking stops. 15 minutes. And surveys of coastal residents in Oregon and Washington have shown that a significant percentage are either unaware of this or do not have a plan. If you live in the Pacific Northwest, if you live anywhere along the Cascadia Zone, this video is for you specifically. You need to know your inundation zone. You need to know your evacuation route. You need to know that when the ground starts shaking and it does not stop, when it keeps shaking for 4 minutes, 5 minutes, that is not a normal earthquake. That is the signal. And you do not wait for a siren. You do not wait for a phone alert. You move immediately to high ground and you do not stop. That knowledge, that preparation, that is the difference between a survivable event and an unsurvivable one. Because the Pacific Ring of Fire does not care about our timelines, it does not check whether we are ready. It moves when the physics says it is time to move. And right now, the physics across the Pacific system is telling us something that everyone should be paying attention to. Indonesia is shaking in one of the most complex tectonic zones on the planet. New Zealand's subduction interface is silently slipping and transferring stress. Cascadia has been locked for 325 years and is showing its own stress signals. And the Pacific Plate, that enormous engine that drives all of this, is releasing energy at multiple boundaries in a compressed time frame. Is this the synchronization of the Ring of Fire? Can a geologist say that with certainty? No. The science does not allow for that certainty right now. What the science does allow us to say is that the current pattern of distributed major seismic activity across the Pacific system is noteworthy, is above baseline, is the kind of pattern that appears in the historical record before significant escalation events. And I think you deserve to know that. I think the 3 million people in the Pacific Northwest deserve to know that. I think the people living along New Zealand's coastlines deserve to know that. I will stay on the pulse of this for you. If a significant event develops in any of these regions, if monitoring data shows a meaningful change, you will hear about it here. Check out the video in the end screen about the Cascadia Subduction Zone in detail. I go deep into the geology and the preparedness numbers, and it will genuinely change how you think about living in that region. If you want to support the channel, coffee link is in the description. No brand deals, no sponsors, just the work. And if you want to become a member, click the join button. Thank you guys. Seriously, stay safe, be aware, look up, look down, look left, look right, anywhere basically. Bye bye.